In this video, we're going to try and understand why it is that when you try and integrate 1 over x, it gives you natural log of the absolute value of x. So start out with our 1 over x graph, which looks like this. You trying to integrate 1 over x, it's really you searching for something in such a way that when you differentiate it, it gives you 1 over x. Now cast your mind back to when we were trying to differentiate natural log of x. If you start out with with natural log of x, if you differentiate this, to differentiate this, you would exponentiate both sides. So exponentiate both sides. That would then give you this, and then the right hand side. In a way, these two they cancel each other out. That would then give you x, and then tidy the right hand side. That will then give you this. This remains the same. So now use implicit differentiation. So when you differentiate this, it will be itself. But because y is a function of x, you need to stick dy by dx, and then differentiate this. That would be 1. So now you're trying to isolate dy by dx. So you would divide both sides by e to the power of y. So that would then give you 1 over e to the power of y. But you don't want the answer in terms of y. So you would then go back to here and realize that that e to the power of y is x. So you can put x into here. So that would then become 1 over x. So when you differentiate natural log of x, it gives you 1 over x. So going back to here, you trying to integrate 1 over x, it's really you searching for something in such a way that when you differentiate it, it gives you 1 over x. Well, natural log of x, if you try and differentiate this, it gives you 1 over x. But here we've got the absolute. So let's try and understand why. So you trying to integrate 1 over x, it's really you searching for something in such a way that when you differentiate it, it gives you 1 over x. Well, natural log of x. But then if you look at the natural log of x graph, it looks like this. If you look at the derivative, it will give you this red line here. But that's just half of the 1 over x graph. Here you still got the negative side. You see the domain for the natural log of x. The domain for the natural log of x is x being greater than 0. The domain for natural log of x has to be is everything on the right hand side. So the domain the domain of natural log of x is never in the negative realm. But the thing is, when you try and look for something in such a way that when you differentiate it, it gives you 1 over x. Here you're neglecting the negative side. So you try. Well, in order for you to integrate 1 over x, you need to take care of this negative side. So you're really looking for something in such a way that when you differentiate it, it gives you this part. So if you look at this, whatever it may be, it must be going downhill. It must be going downhill because your red line's in the negative realm. And then by the time it gets to around here, whatever it may be, it must be really, really steep as you head towards here. So as it turns out, it's like this. You see, when you're trying to look for something that when you differentiate this, it gives you the red line. It's actually something like this. It looks something like this. It looks something like this. You see, it is going downhill, and you can see the red line here is in the negative realm, and then by the time it gets to around here, it gets really, really steep. So it's going downhill very, very fast. Now, if you look at the red line, it is in the negative realm, and it's going down really fast as well. As it turns out, to take care of this negative side, you would take the absolute value of x. And then that will then take care of the negative side, and then plus c. So to integrate 1 over x, you need to take care of this negative side, and the way you do that is to stick the absolute value of x in here. So when you differentiate this, it will then give you both sides. Okay, so if you look at this, if you get a graph plotter and plot y equals natural log absolute value of x here, it will then give you this and this. So so when you differentiate this blue line here, it will then give you this red line here. So to integrate this, it will then give you this. Okay.